Hello and welcome to another video on the RF Workshop channel. Today's video is going to be about fixing the crack in this water pump cover for my Suzuki TS200R. This is a bike that I'd recently just bought. It's new to me. I can only guess that one of the previous owners has clipped a stump or a rock or something as they're riding along. This cover normally faces this way. It's contacted the flange here and has put such a strain on the cover that it's actually cracked from this point here all the way around, branches off here into another crack, a little wire split there, into the threads here. So the plan of attack is to get the die grinder and then make a well following along the crack and then use these low temperature aluminium soldering rods to fill up that well. These rods I got for just under 40 Australian dollars including postage. They were from an Australian seller. They should act similarly to the way lead solder does on copper, would be my understanding. Apparently to use these rods you only need a standard propane blowtorch. Before I actually start work on the cover however, I'm going to have a practice on this piston here. No, this hole didn't happen while it was in the engine. This piston is melted because I've used it for testing other things in the past. Now I have ground down the top of this piston so there shouldn't be any contaminants on top that should interfere with what I'm trying to do here. Now I understand this process should be similar to soldering copper. So what I'll do is heat up the part and then use the heat from the part to melt the rod. Okay, so I've put 3 different beads on there using different procedures. The first one I just dragged the rod across, trying to scratch the piston while I was doing that. The one on the top, unfortunately, I forgot to turn the camera on, and I basically did a standard C pattern you would use while using a MIG welder with mild steel. And the bottom I just use a very light scratching, smaller, more confined C pattern. Okay, here we are back on the workbench. So what I'm going to do now is just test to see how well the rod has bitten into the aluminium. Unfortunately, I was impatient during the cooling process, and I did quench the piston with water. You really shouldn't do that with this kind of thing. Because different metals expand and contracts at different rates during cooling, it's really not going to be helpful for a good strong connection. So because of my impatience, it's probably not a good representation of how the product would perform if it was actually being used correctly. As you can see, not much strength with that one. It's a good sign, it passes the fingernail test. This one is the one where I just dragged the rod across the surface, but these two I used a little bit of a scratching C pattern. I was able to flick them all off just by pushing with a chisel, but I don't think that's the product's fault. So what I'm going to do now, try the procedure that worked the best, which was the scratching C pattern. Grind down the surface again and see how we go after attempt 2. I am going to cut off the end of the rod from the last session because the whatever flux is in it will be cooked. Okay, something I noticed during that attempt was the rod refused to melt when I was contacting the piston until I put just a little bit of heat on it from the blowtorch. Almost like the piston was at the correct temperature for melting the rod, but there wasn't enough heat transference between the two to actually start liquefying the rod material. So I think I might keep that in mind for when I'm doing the final part. I'll put a little bit of heat into the rod with the torch right at the end. I don't want the part crystallizing or becoming molten itself. Okay, so while the piston's outside cooling down properly, I'm going to use this die grinder with this end bit just to chase the crack along the cover to create a weld to fill up with the aluminium soldering rod. If however the piston cools after I've made this weld, and I'm not satisfied with how well the rod has bitten into the metal, I'll just fill up this well with epoxy. Definitely too hard to do one-handed, so I'll come back when it's finished. Okay, so that's the well done. The grinding head kept changing shape, so it was hard to get a nice deep well without going too wide. And there was also several derailments which caused some unnecessary damage. So now I'll go out and check on the piston, see how that's going, and then solder this up if all is hunky-dory. Okay, so remember the procedure for this was heat up with propane blowtorch, scratch in a C pattern, and then cool down naturally. I've also ground down the face of the piston so there shouldn't be any contaminants and minimal oxidization. And I also put just a tiny bit of heat into the rod before I started welding it. Not enough to bake out any flux, I wouldn't think, but because the piston seemed to be having trouble transferring heat to the rod just at the beginning. Okay, so I don't seem to be able to flick the bead off with just a chisel by hand, so that's probably already better than a lot of glues or a lot of resins. So I'm happy to proceed ahead and heat up the actual part now. Okay, so that's the result after a little bit of mucking around. I went over it once with a bead, and then I didn't feel there was enough material, so I tried heating it again, and then going over it once again. I thought maybe that would also help the aluminium material get further into the crack. So what I'll do now is just let it cool down and then grind off the ugly surface, and then either leave it how it is or try again. Okay, so I've cleaned things up with the die grinder a little bit. Doesn't look like it on camera, but I'm going to have one more attempt at filling that canal and we'll see how we go. Right, that's up to the final pass. I'll wait for it to cool down now, clean it up with the die grinder, and then I'll put it in a sandblaster to see if I can get a bit more of a natural cast aluminium finish. Here it is. Could probably make it look better if I wanted to, but it's going to be covered with a pipe there anyway. If any of those voids decides to leak, I'll just blast the paint off and then do it all again. Alright, I couldn't help myself. This is attempt 2. Okay, so this is attempt 2 after a paint. As you can see, there's no voids. One of the voids in the previous attempt leaked, so I figured I might as well just try and do the best job I can, which is risky because every time you heat this up there's risk of making it warp. I did shave a little bit off of it because I thought in a couple of places it did slightly, but I think I'm lucky. I've gotten lucky with the result, and I think it looks quite good for something that was previously cracked around half of its perimeter. While I'm here, I also have this magneto cover and sprocket cover to install. They've all been painted with the same paint, so they all match nicely. So I figure I might as well get those done first. Okay, so I'm going to put this cover and the sprocket cover on now. I'd just like to say a word of advice for anyone that likes to do this themselves. I have seen a few people make this mistake despite having years of experience. You should always try to dig out any material out of the bolt holes before you put the bolts in on any cover, because if there's material in the inside those holes and there's no hole on the other side of the thread for it to escape, you can end up compressing any kind of dirt or whatever's got, or gasket group or whatever's gotten into the hole with the bolt, and you can end up cracking the engine case. The thread splits in half because the material's got to go somewhere when it's being compressed. that's those covers installed. I know I might get some comments about using black on side covers and how it wears off, but I believe the plastic for the sprocket cover is actually black itself, so that shouldn't matter. But the magneto cover is like a cream fiberglass colour. So yes, it will happen, but the paint's cheap, so I'll just spray it again. Well, I guess I spoke too soon about being lucky with this cover, because when I tried to put the O-ring gasket in, I noticed there was a like a lump, a bulge in where the groove in where the gasket sits. So what I've done is I've got the die grinder and then just ground like a relief path through it that the O-ring can sit in, so it doesn't protrude too much further than everything else. It shouldn't really matter because the O-ring should just squish anyway. It was pretty severe, the bump that was in it. Right, so I just checked the mechanical seal behind the impeller and it is just about cactus, so that's something that I'll have to order. But until then, I'll just button everything up and see how we go. Well, I was about to do everything back up, but I just thought I did shave a little bit off of the cover because it was slightly warped, just to make it a bit more flat. And I'm wondering now if the water pump impeller is still going to clear the inside of the cover. So this thing probably has plastic gears in it, if I was to guess, that drive the water pump. So I'm just going to take it off and measure some things, just to be 100% sure that I'm not going to have to pull the engine apart and replace gears that may or may not grind. Well, everything in there is nice and shiny. Okay, so I don't have the correct plug that would normally fit in here. So what I've done is I've gotten a standard bolt with the threads to match. I've shortened it using the lathe and put a copper sealing washer on it. So this should be enough to just seal things how we need at the moment, and eventually I'll get something that would be the correct for this application. This would probably already do a pretty good job though. Okay, so unfortunately that's going to have to do it for this video. I would like to provide a bit more closure with perhaps a shot of me filling up the system with coolant. I'd like to flush this system with straight water first, because the whatever the previous owner put in it turned to jelly when I drained everything. And in order to do that, I'm going to have to start the bike and let it run a bit, and I can't do that yet because I'm still missing some bits, such as the oil reservoir tank and a few other things I need to actually run the bike. This is my project bike. I've been rebuilding things. I have other videos of restoring other components, including the exhaust, fuel tank, shrouds, radiators. Feel free to click the subscribe button and I should soon have a video providing a bit more closure to this project. Otherwise, I hope you enjoyed the video. Thanks for watching. Catch you next time.